All right, so this is the second video for 5.1 notes. We're going to go over Pascal's triangle and how that's going to be used for binomial expansion. So binomial expansion is when we're going to have two terms raised to an exponent of anything. Typically, you're going to use Pascal's triangle for if you have an exponent that's 3 or larger. And it's just a method that is used to help simplify the work for expanding, because every time we raise something to the power of 3 or every time we raise it to the power of 4, there is a pattern that is followed every single time. So that's where Pascal's triangle comes in. So this is Pascal's triangle, and you'll notice there are ones going all the way along the sides on the left and the right. And for those other numbers, they are found by adding the two above. So if we look at this 2 here, oops, sorry, pen's not writing. This 2, okay. So that 2 that I have a box around, that was found by taking the two numbers above it on either side and adding them together. And you'll notice that pattern follows. So if we look at the 3 over here, this 3 was found by taking the 1 and the 2 above it and adding it together. Same thing with the 3 next to it. We took the 2 and the 1 that were above it, added them together. And that pattern continues throughout this triangle. Knowing how to write this triangle is going to be important because it's not going to be given to you on a quiz or a test. And this explanation for binomial expansion over on the right, that's also not going to be given to you. So it is very important that you know how to draw it. So we're going to do practice. So over here in this space, we're going to draw a triangle. So it's always going to start with 3 1s. Then our next row, we're going to have 1 on the outside, and remember the number below it, so here in the middle, is going to be found by adding the two numbers above it together. So 1 plus 1 is going to be 2. Then we do the same thing. So it's going to start with 1, and then this number here next is going to be found by adding the 1 and the 2 above it together. So 1 plus 2 is 3. Oops. Then again over here, this number is going to be found by adding the numbers above it together. So 2 plus 1 is 3. We'll put that there. And then it will end with a 1 on the side. Now we're going to do that again for the next row. So we have a 1. And then for the next space, we're going to look at the two numbers above it and add it together. So 1 plus 3 is 4. Then we move on. The next one, we'll have 3 plus 3 is 6. And then next, we'll have 3 plus 1, and that will be 4. And the end of our row is going to end with a 1 again. When you're drawing this, the highest we're going to need to go is 6 rows into our pyramid. And so we need 1 more. So we'll have, again, starting with a 1. The next place value will be found by adding 1 plus 4, which is 5. Then we'll keep going. 4 plus 6, those two are above this. Those will give us a 10. Then next, another 4 plus 6. That also gives us a 10. Oh, sorry, my screen went away. And then our last two that we're going to add together, a 4 and a 1, which is 5. And you'll notice that these rows are very symmetrical. So we have a 1 3 and then a 3 1. And the next one we had a 1 4 6, and then we have a 4 1 on the other side of it. And now we have 1 5 10 and a 10 5 1. So they are very symmetrical, a lot of repeating numbers in this. So don't be alarmed if you get the same numbers. Okay. So these numbers come in when we're using binomial expansion. You'll notice the first one just has one number. That is when we have an exponent of 0, so power of 0. And that works because everything raised to the power of 0 always equals 1. So if you see an exponent of 0, anything it's an exponent of equals 1. Then our next one, we have an exponent of 1. So that just means we're going to have 1 of each of our terms, so 1a and 1b. Then our next row is an exponent of 2. And you'll notice from before, when we FOILed anything that had the same set of parentheses, we ended up with 3 terms. So this one row has an exponent of 2. So for that, you're going to have whatever your A value is and your B value, and those are going to be both squared at the end, and then it's 2AB in the middle. So that's where those numbers are going to come in. They're going to help us simplify to figure out what each of these terms would equal once we have FOILed it out. Okay, so now we're going to do an example. And once we do a couple of examples, it'll make more sense what I'm saying here. So for example 2a, we have x plus 2 in parentheses squared, or cubed, sorry. So we're going to go to our triangle and we're going to go to the one of the power of 3. So right now the top row is the power of 0, then we have the power of 1, the power of 2, now we have the power of 3. So we are going to be using this row in our triangle. So these are the coefficients that we are going to start with. And we want to make sure we don't go too far over into the B section because that one's going to be a little bit longer. So over here, we're going to start with our coefficients. So we're going to have 1, we're going to leave a little bit of space and then put plus 3. Leave some space, plus 3, leave some space, and then plus 1. Now behind each of these, we are going to write our A and our B values. And A is going to be the first term that is in our parentheses, and then B is going to be the second term that's in the parentheses. And each of those are going to be written right next to our coefficients. So we'll have our X. So that's our A value. Then we're going to write our B value, which is 2. So the first thing you're going to write down are your coefficients, followed by your A and your B values. Then next, we're going to write down the exponents. The exponent for your A value is going to start as the same exponent that's on your set of parentheses. So we're going to start this x to the power of 3, x to the power of 2, 1, and then 0. Then we do the opposite with our B value. Our B value is going to start with 0 and then go up by 1. One way that you can double check that you have set up your exponents correctly, whenever you add the two exponents from the same term together, their sum should be the exponent that's on your original binomial. So 3 plus 0 equals 3. And then if we check our second term, 2 plus 1 equals 3. 1 plus 2 equals 3. 0 plus 3 equals 3. So all of those exponents in each term have to add up to 3, otherwise you wrote the wrong exponent and you need to make some adjustments. Okay, now this is our second step. So we've added our coefficients, A and B values, then we wrote our exponents. The next thing you're just going to do is simplify every term. So we're going to simplify everything that's possible. If we look, and this part would be on the calculator portion of the test. So if you are not very confident with your exponent evaluating, that is okay. We will get there. You can use a calculator to check your answers. What you would want to type into your calculator is just the number values. So over here we would have 1 times and then 2 to the power of 0. So if you don't know that off the top of your head, which you should, but if not, that's okay. We would get 1 times 2 to the power of 0 equals 1. So we would just have 1x power of 3. And because it's 1, we don't really need that in front. If you write it, that's okay, but it's not necessary. Okay, so then for our second term, we have a 3 and then a 2 raised to the power of 1. So on my calculator, if you don't know that off the top of your head, you would just do 3 times 2 to the power of 1. And that gives us 6. So then we would put plus 6, and don't forget your x term. So then we would have x squared. Then we move on to our next one. We have 3 times 2 to the power of 2. and that comes out to equal 12. So we would have 12x to the power of 1. And again, x to the power of 1 and x mean the exact same thing. So if you don't put that 1 there, you don't have to. If you do, that's okay as well. And then our last term, we have 1 times 2 to the power of 3. And that comes out to equal 8. And with this one, our last term has x to the power of 0. And we did talk about how anything to the power of 0 equals 1. So that last term is going to be your constant. There are not going to be any x's with it because the power of 0 changes it to a 1 and then we no longer have it. After you simplify, that is your final answer. So we did Pascal's triangle to simplify this binomial instead of writing out x plus 2 3 times and then foiling it. So we would have to FOIL this here, and then eventually once we get that, which would be x squared plus 4x plus 4, we would then have to multiply that all by this. And then we would have to combine all of our like terms, and that just leaves a lot of room for error, sorry. So Pascal's triangle will help avoid having to do all that work and also avoid having as many opportunities to make mathematical mistakes. So that's why we use Pascal's triangle, to save time and to be more efficient. Okay, so we're going to set up the next one together, but then I would recommend pausing partway through to see if you know how to evaluate them on your own. So this one is to the power of 5. So if we look at our triangle that we drew, we had power 0, 1, 2, 3. The next one would be 4, which leads us to 5 on the bottom of the one we drew. So this is going to be our list of coefficients that we're going to use. So we have a 1, leave some space, plus 5, leave some space, plus 10, some space, plus 10, and then a 5, and then a 1. Okay, so now for this one, we want to be careful. Our A value is a 2x, and then our B value is a 1. So there's going to be a slightly more work on this one, but don't worry, we will get through it. All right, I'm going to change the color on this. B equals 1. Okay. So once you have your coefficients, then we write our A and our B values next to them. So we have our 2x as our A. That's going to be next to everything. Then we're going to write our B value, and this one's 1. Then, so we've wrote our coefficients with A and B. Second step is to write your exponents. And remember, your exponents for the A value start with the same exponent in your parentheses. So we'll have a 5, 4, 3, 2, 1, and 0. Then the exponents for our B value will go the opposite direction. So they start with 0, and then they go up by 1. And remember, each of these exponents on the terms should add up to 5. So 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, and so forth. So make sure that your exponents on the term will add up to 5. Once you're there, then you are going to simplify. And you do have a calculator for this part, so if you need to, you can use that to help you evaluate. So looking at this first one, we have a 1 and then a 1 to the power 0, but this one has a coefficient in front of x. So remember, when there's parentheses and we have an exponent, this means we have 2 to the power 5 and x to the power 5. So we also need to include that 2 to the power 5 when we're trying to evaluate what the new coefficient would be. So on my calculator, if you need to use that, you're going to do 1 times 2 to the power of 5, and then times the 1 to the power of 0. That will give us the coefficient for our first term, and that'll be 32. And make sure you don't forget then your x to the power of 5 next to that. Okay, Now let's move on to the next one. So for the next one, on our calculator, we would have our 5, 2 to the power of 4, and then 1 to the power of 1. So 5 times 2 to the power of 4, and then times 1 to the power of 1. That gives us our coefficient of 80. So we would have plus 80 x to the power of 4. Then our next term, it starts with a 10, 2 to the power of 3, because remember that 3 is applied to both the 2 and the x, and then 1 to the power of 2. Oops, I did not type that in correctly. There we go. Okay, so 2 to the power of 3 times 1 squared. There we go. And that one also comes out to 80. It is okay to get the same coefficient more than once in a row. Depending on what your values are that you're plugging in for A and B, that can happen. So don't panic if you get the same numbers. Okay, so this would be a great time to pause and see if you know how to do the next 3 on your own. So go ahead, pause the video, see if you can do them, and then hit play, and then you can jump to the end to see if you have the correct answer. And if not, you can rewind to see what you should have been doing. Okay, so hopefully now you have your answers. The next one, we would have 10 times 2 squared times 1 to the 3. Okay, so then once you get that all typed in, it should come out to be 40. And if you got the wrong number and you're using your calculator, make sure it looks like my calculator over on the left. And this one should be 40x squared. Then your next one, we had 5 times 2 to the power of 1, and then times 1 to the power of 4. That one should come out to a 10x. And our last term, remember this one is our constant term because we have that power of 0. So if you type it into your calculator just to double check, it would end up coming out to 1 for this one as well. And that is our simplified answer. And again, we do it this way to avoid having to write out 2x plus 1 5 times and then multiplying it. So instead of doing this work that I am writing down right now, we are able to use Pascal's triangle to save us time and then also to be more efficient with our answer. Okay. The next video will show example 2C. If you feel like you are good on Pascal's triangle and simplifying these, you can skip it and then jump to the 4th video for the rest of the notes.